So the ones that we did in class, I'm not going to do them again, but I'll also post Miss Boyd's video because she did all of them, I think in 2 separate videos. So I'll post her video on Canvas also in addition to this video. That way if you still have questions about the ones we did yesterday, it'll be in her video. I already posted the answers to all of these on Canvas too. So the PDF of the answers is already up. But let's take a look at number 2. So what's the first thing we have to do here?
Find the opposite.
Find the opposite. So how do we find the opposite?
Pythagorean theorem.
Pythagorean theorem. So we have 3 squared plus b squared is equal to 6 squared. So 6 has to be our c squared because it's the hypotenuse. So we have 9 plus b squared is equal to 36. Subtract 9 on both sides. So b squared is equal to 36 minus 9 is 27. Take the square root of both sides. So what do we get for b?
3 times square root of 3.
Awesome. 3 times square root of 3. So 3 square root 3 is our opposite. 3 is our adjacent. And 6 is our hypotenuse. All 3 of these triangles look the same, and theta is down in the left corner, but just keep in mind that if theta is up here, then this one down here would be your opposite. So just make sure you keep an eye out for where your theta is for your test tomorrow. All right, so let's find our sine first. So what would sine be?
It would be 3 times square root of 3 over 6.
Awesome. So sine is opposite over hypotenuse. So 3 square root 3 over 6. The 3 on top can simplify with the 6 on the bottom. So then we just have square root 3 over 2. Going back to see how somebody asked a question about how we got from square root 27 to 3 square root 3. So I'll do that over here. Square root 27, what are 2 factors of 27?
9 and 3.
9 and 3. What are 2 factors of 9?
3 and 3.
3 and 3. So then for our square root, we have 3 times 3 times 3. We can take out any pairs, but we just take out one of them. So we have 3 square root 3. So that's how we got this.
If we left square root of 27, would we get points off for tomorrow's test?
Your answer here has to be as simplified as possible. So yes. If you wanted to leave it as square root 27 and then simplify once you get to this part, you can do that. But just make sure all your answers are as simplified as can be.
Thank you.
You're welcome. All right, so next we have cosine. Cosine is adjacent over hypotenuse. So we have 3 over 6. What does this simplify to?
1/2.
1/2. Then we have tangent, which is opposite over adjacent. So 3 square root 3 over 3. And what does this simplify to?
Would it be
Square root of 3.
Square root 3. So the 3's cancel out. So we're just left with square root 3. Okay, next we have the reciprocals of all of them. So cosecant. Cosecant, we flip sine, so it's hypotenuse over opposite. So 6 over 3 square root 3. Or if you just wanted to flip this, you could too. We'd get the same answer.
So it'd be 2 times square root of 3 over
Yeah. So this would be 2 square root 3 over 3. Perfect. All right, next we have secant. Secant is hypotenuse over adjacent, or we could just flip the cosine. So 1 over 2 would be 2 over 1, which is just 2. And then lastly, cotangent. We just flip tangent. So it would be 1 over square root 3. Can we leave our answer like this?
Have to rationalize.
Have to rationalize. So multiply the top and the bottom by square root 3. And what do we get?
Square root of 3 over 3.
Perfect. So these are our 6 trig functions here. Any questions on this one? All right, let's look at number 3. So yesterday in class, we found the opposite, which was 5. So again, we just did Pythagorean theorem. Just be careful when you're doing Pythagorean theorem. If you have something like 5 square root 2 squared, you have to square the 5 and square the square root 2. So 5 squared would be 25. Square root 2 squared is 2. So 25 times 2 would give us 50. So just be careful with that. So once we have all 3 of the sides of our triangle, this one would be adjacent, this one's opposite, this one's hypotenuse. First, let's find our sine. So what would our sine of theta be?
5 over 5 times square root of 2.
Perfect. And then how can we simplify this?
You just multiply it by the square root of 2.
Awesome. So the 5s cancel out, so we have 1 over square root 2, and then we multiply the top and the bottom by square root 2. So we get square root 2 over 2. Next, let's find our cosine. So cosine is adjacent over hypotenuse. What would our cosine be here?
It would be square root of 2 over 2.
Perfect. So we get 5 over 5 square root 2, which is the same as sine, so we know it's going to simplify as square root 2 over 2. Next, we have tangent. What would our tangent be?
1.
1. Awesome, because we got 5 over 5, and that simplifies. And then our cosecant.
Square root of 2.
Perfect. So we get 5 square root 2 over 5, and the 5s cancel. And then secant.
Same thing.
Same thing. And then cotangent.
1 again.
1 again. Perfect. Any questions on these?
Miss Carver,
Mm-hmm.
to find out what, like, the 5 that was missing on the triangle, could you also do, like, the perfect right triangles?
Yeah, if you know your like special right triangles, and you see that this one's 5, this one's 5 square root 2, then you would know that this one's going to be 5. Yeah, so you wouldn't even need to use Pythagorean theorem if you know that.
Okay, thank you.
You're welcome. All right, number 4. So it gives us cotangent of theta is equal to 6. Where do we start here? What do we do first?
But you want to find the other side
Right.
since it's technically 6 over 1.
Awesome. So we have 6 over 1. What is 6 compared to theta, and what's 1?
6 is adjacent.
And 1?
Or, oh, no, this is cotangent, so never mind.
Well, so...
It's both sides, not the hypotenuse.
Right. So 1 would be the opposite. Because tangent is TOA, so it's opposite over adjacent. So cotan would be the reciprocal, so adjacent over opposite. So adjacent is 6, opposite is 1. And then we need to do Pythagorean theorem to find the missing side. So we have 1 squared plus 6 squared is equal to c squared. 1 plus 36 is equal to c squared. 37 is equal to c squared. Take the square root of both sides. So square root 37 is equal to c. Can we simplify the square root of 37?
No.
Nope. So we can just leave it as that. All right, now let's find the sine of theta. So what would our sine be?
1 over...
1 over square root.
Perfect. 1 over square root 37. Got to multiply the top and the bottom by square root 37. So we get square root 37 over 37. Next, let's find our tangent. Tangent is opposite over adjacent. So what would tangent be?
One over 6.
Perfect. 1 over 6. Now our cosecant.
$37 over square root of 37.
Yeah, we could just flip this, or we could see that before we rationalized, we had this, so we just flip that one. So it would just be square root 37. Because cosecant is hypotenuse over adjacent, so 37, or hypotenuse over opposite, so 37 over 1. All right, secant. Secant would be hypotenuse over adjacent. So our hypotenuse is square root 37, and our adjacent is 6. So square root 37 over 6. And then lastly, our cosine. We flip the secant. So this is adjacent over hypotenuse, so 6 over square root 37. Got to rationalize. So 6 square root 37 over 37. Any questions on this one? No questions? All right, I'm going to skip 5. If we have time, I'll come back to it. I'm pretty sure we did 6 in class, but we'll do it again. Oh, we did 6 in the review of 4.3, so it's a little bit different. All right, so what do you want to find first, x or r?
X.
Sure, let's find x. So if this is our theta, 30 is our theta, x is opposite, 39 is adjacent, and r is hypotenuse. So we're looking for x first. So we have opposite and adjacent. What involves opposite and adjacent? Tangent. So we're going to find the tan of 30, and that's equal to opposite over adjacent, so x over 39. Now we need to go back to our notes and find what the tangent of 30 is, because this asks for the exact value. So we can't just put in our calculator. So what's tan of 30?
Could you also do cosine of 30?
We could do cosine to find r, but first we're finding x.
Oh, okay. You want to multiply the 39 both sides?
Yep, or we can just cross multiply. But yeah, you would do it
Oh, yeah.
pretty much the same thing. So 39 square root 3 is equal to 3x. Then just divide by 3. Can we simplify 39 square root 3 over 3? Can we simplify?
Yeah, you can. It's 13 times square root of 3.
Awesome. So 3 goes into 39, so this would be 13 square root 3. So we found x, now we have to find r. So we can use adjacent, and r is our hypotenuse. So what involves adjacent and hypotenuse?
Cosine?
Cosine.
So we're going to find the cosine of 30, which is equal to adjacent, so 39 over hypotenuse, which is r. So going back to our chart, what's the cosine of 30?
Square root of 3 over 2.
Perfect, square root 3 over 2. Can you guys, oh, there we go. Square root 3 over 2. And that's equal to 39 over r. So how can we solve for r?
Cross multiply?
Cross multiply. So r square root 3 is equal to 39 times 2, which is 78. Divide both sides by square root 3. So r is equal to 78 over square root 3. Can we leave our answer like this?
No.
Nope, have to rationalize. So multiply the top and the bottom by square root 3. So we get 78 square root 3 over 3. Can we simplify this?
Yes.
Yep, what do we get?
26 times square root of 3.
Yes, 26 square root 3. Perfect. Any questions on this one? So remember, when it asks for the exact value, you have to use that chart from the notes. All right, so we did number 7 in class yesterday, so let's look at number 8. A ladder is laying against the side of a 3-story house. A roofer measures the angle of depression from the roof line to the sidewalk to be 58 degrees. The base of the ladder is 65 feet from the base of the house. How long is the ladder? So a ladder is lying against the side of the 3-story building. So this is our building. This is our ladder. A roofer measures the angle of depression. So angle of depression is from the horizontal line down. So our angle of depression would actually be from here down. So this is 58 degrees. And then the base of the ladder is 65 feet from the base of the house. So here we have 65 feet. We're looking for how long is the ladder. All right, so what should we do first?
You want to find the other side, the side that's next to the building.
How could we do that?
So you have 58 degrees, that's the angle of depression. You can assume that the angle on the bottom is the same.
So you're saying that this is 58 also?
No, the one on the
Oh,
bottom
down
left.
here. Okay, that's a good observation because you know that these are parallel lines. So this would also be 58. That would work. Another way you could do it, I didn't think about it that way, but this is a right angle because this is horizontal and this is straight. So we could just do 90 minus 58 to find what this angle here is. And we could use that as our theta. So either way would work.
Oh, okay.
But you're right. You could definitely say that this angle is 58. So that works too. So if we used this one as 58, then 65, this is our theta. 65 would be opposite or adjacent?
Adjacent.
Adjacent. And then x would be the hypotenuse. So then we can do what involves adjacent and hypotenuse?
Cosine.
Cosine. So we can do the cosine of 58 is equal to 65 over x. So then we would need to use our calculator to find the cosine of 58. So this would be 0.5299 is equal to 65 over x. How do we solve for x here?
You divide by 65.
Divide. We shouldn't divide by 65.
Which means you flip.
We can cross multiply. We would just say this is 0.5299 over 1. So we would get 0.5299x is equal to 65. And then we would just divide by 0.5299. So if we divided by 65 here, x would still be on the bottom, so that wouldn't work. So 65 divided by 0.5299 is 122.66. That would be in feet. Does everybody agree with that?
Yes.
When I did the solutions, I used this as theta, so I had to do 90 minus 58, which gave me 32 as my theta. So then I did sine of 32. So there's more than one way to do this. If you did it a different way, but still got the right answer, totally fine. So as long as you get 122.66, then you're good. Any questions on this one?
How many of these are going to be on the test tomorrow?
The word problems?
Yeah.
I think only one, maybe two. There's only 10 questions total, but like some of them involve like two parts, like this one where you have to find x and r, these where you have to find like the trig functions. It won't ask you for all 6 trig functions, but it'll be like find sine and cotangent, something like that. It'll pick 2 random ones. So there's only 10 questions, but a good amount of them have 2 parts to it. All right, let's go to the next page. Let's look at number 10. How would we convert this to degrees?
You would multiply it by 180 over pi.
Awesome. 180 over pi. So the pi's cancel out. We have 3 times 180, which is, let's see, 540 divided by 19.
28.4.
28.4. Perfect. I'm going to skip 11 for now and go to 12. So we need the complement and supplement if possible. So to find the complement, remember we have 2 angles that add up to what?
90.
90, but if you notice all of these are in radians, so it's got to be in radians. What's 90?
Pi over 2.
Pi over 2. And then supplement, they add up to what?
Pi.
Pi. So we have pi over 3 plus some angle that's going to be equal to pi over 2. So we can say pi over 2 minus the angle that's given, so pi over 3, and that's going to be our complement. In order to subtract fractions, need the same denominator, so I'm going to multiply the first one, the top and the bottom, by 3 to give me 6 on the denominator, and then the second one I have to multiply the top and the bottom by 2, so I have 6. So our denominator stays the same. Just subtract the numerators, so we have 3 pi minus 2 pi, which is just pi. So our complement is pi over 6. Supplement, we do the same thing, but instead we start with pi minus pi over 3. Again, we need our denominators to be the same, so for the first one, I'm going to multiply the top and the bottom by 3. So I have 3 pi minus pi, which is 2 pi over 3. This is our supplement. Any questions on this one?
Nope.
All right, 13. So our complement, we do pi over 2 minus the angle that's given, so 5 pi over 6. Need our denominators to be the same, so I'm going to multiply the top and the bottom by 3. So I have 3 pi over 6. Subtract the numerators. What's 3 pi minus 5 pi?
It would be negative, so therefore there's no angle.
Awesome.
Or radius.
It would be negative 2 pi over 6. Can't have a negative complement or supplement, so we have no complement here. A lot of people made that mistake on the quiz. You cannot have a negative complement or supplement. They always have to be positive. So if you get a negative, there's no complement. All right, let's find the supplement. So we have pi minus 5 pi over 6. For pi, we have to multiply the top and the bottom by 6. So what's 6 pi minus 5 pi? Just pi. So pi over 6 would be our supplement. For 14, when we subtract, they are both negative. So 14, we have no complement, and no supplement. So complement and supplement cannot be negative. Okay, let's do 15. So give all 6 trig functions. First thing we need to do is find 3 pi over 2 on our unit circle. So that would be down here. So our coordinate is 0, comma, -1. This is our x, this is our y. What would sine of theta be?
Y.
-1.
It's y, so -1. What about cosine?
0.
0. What about tangent?
Is it undefined?
Awesome. It would be -1 over 0. We can't have 0 in the denominator, so this would be undefined. Okay, next we have cosecant. What would cosecant be?
-1.
-1. Perfect. What about secant?
Undefined.
Undefined, because we would have 1 over 0. So we get undefined. And then cotangent?
0.
Perfect. Cotangent is 0. Any questions on this one?
So this one's just looking at the chart
Yeah.
and then knowing the x and y's.
Mm-hmm.
Okay.
Yep, so you just have to know that like sine is y, cosine is x. So just know like which one's which. And you just look at the chart and then plug everything in. Okay, last page. Number 18. So you have to find the linear speed of the second hands of a clock given the info below. So for linear speed, our formula is radius times theta over time. So theta and time are going to come from that chart from the notes. So for a half revolution, what would our theta be?
Pi.
Pi. And then what would our time be?
30 seconds.
Perfect, 30 seconds. Remember, theta is always in radians. So even though on that chart it says 180 degrees, we only care about the pi because we only want to deal with radians. Now we just plug it in. So we have 1.72 times pi over 30. Just got to put it into our calculator. 1.72 times 3.14 divided by 30 gives us 0.18. This would be centimeters per second.
When we use pi, we should use 3.14.
We have to make sure we have the unit right.
Yes, make sure you have the unit. Also, if it's degrees, make sure you put the little degrees symbol. And you can use 3.14 or you can use like the pi button if your calculator has a pi button. Either one would work.
Okay, if we use the pi button, should we round to a specific place?
It'll tell you to round to 2 decimals or 3 decimals. It'll be specific.
Thank you.
You're welcome. But also, like, if you're off, like if the third decimal is off a little bit, I'm not going to take points off because of that. Like, I just would know you rounded somewhere. So don't get too worried about whether you use 3.14 or like the actual pi button. Okay, I added this question down here, just in case we see one like this on the test. So it says, given the arc length is 18 yards and the radius is 5 yards, find theta in degrees. What is our arc length formula? Remember, arc length is S, so what's S equal to?
R times theta.
R times theta. So it says our arc length is 18, so we plug that in for S, and our radius is 5. And we need to find theta. What do we need to do to find theta here?
Just divide by S.
That's a 5, but yes, divide by 5. So theta is equal to 18 over 5. Now, is this in degrees, or do we need to convert it?
You have to convert it.
We have to convert it. So anytime we use this formula, we are in radians. So our answer is in radians, so we need to change it to degrees. So how would we change this to degrees?
Multiply by pi over 180.
180 over pi.
180 over pi. So remember, when going to degrees, it's 180 over pi. And then we can just put it into our calculator. So we have 18 times 180, which is 3,240. And then 5 times 3.14, which is 15.7. And divide. We get 206.36, which we could round to 37. And this is degrees. So anytime you're talking about degrees, you just have to put that little degree symbol.